Welcome to CyberXplain channel. Today we are going to discuss unmasking AI threats, why cybercriminals target machine learning vertical bar CyberXplain. Hey everyone, and welcome back to CyberXplain. Today, we are diving into something super hot and incredibly important, the security of artificial intelligence. Think about it, AI is no longer just in sci-fi movies, it's quietly powering so much of our daily lives, from recommending what to watch to detecting fraud. But just like any powerful technology, AI comes with its own set of unique security challenges. Ever wondered what happens if someone tries to hack an AI? We are going to explore exactly that, talking about the sneaky ways attackers try to trick these smart systems. Let's unravel the mysteries of AI security together, in a way that's easy to understand for everyone. We place a lot of trust in AI, sometimes without even realizing it. AI helps doctors diagnose illnesses, decides if your credit card transaction is legitimate, and even powers self-driving cars. So, what happens if an AI makes a wrong decision? Not because it's faulty, but because it's been deliberately tricked. The consequences can range from annoying to truly dangerous, impacting our privacy, safety, and even our finances. That's why securing AI isn't just a technical challenge, it's about maintaining trust in the systems that underpin our modern world. So, let's start with a foundational concept, adversarial machine learning. Sounds fancy, right? But it's actually pretty simple when we break it down. Think of adversarial as having an opponent or an enemy. In cybersecurity, that's usually a hacker trying to mess with your systems. And machine learning is just how computers learn from data without being explicitly programmed for every single task. So, put them together, and you have attackers deliberately trying to confuse or trick AI systems. It's like a game of cat and mouse, but with incredibly smart computers on one side. You might be wondering, why would an attacker bother to hack an AI specifically? Well, the motivations are pretty similar to why they attack any other system, but with some AI-specific twists. Attackers might want to disrupt services, like making a self-driving car crash, or they might aim for financial gain by fooling fraud detection systems. Sometimes, it's about gaining unauthorized access, or even just causing chaos and reputational damage. The power and pervasiveness of AI make it a very attractive target for malicious actors looking for new ways to cause trouble. To understand how AI can be tricked, we first need a basic idea of how it learns. Imagine you are teaching a child to recognize a cat. You show them hundreds of pictures of cats, dogs, birds, and other animals, saying that's a cat or that's not a cat. Over time, the child learns the patterns and features that define a cat. AI works similarly, it's fed massive amounts of data, pictures, text, numbers, and it builds an internal model that learns patterns. This model then makes predictions or decisions based on new data it hasn't seen before. The trick comes in when someone messes with the teaching material or tries to make the AI misinterpret new pictures. When we talk about traditional cybersecurity, we often think about firewalls, operating systems, and network vulnerabilities. But with AI, the attack surface expands significantly. Attackers aren't just looking for open ports, they might target the very data used to train the AI, the internal logic of the AI model itself, or even the way the AI's inputs and outputs are handled. Think of it like this, if you are building a house, traditional security protects the doors and windows. AI security also needs to protect the blueprints, the building materials, and even how people interpret the finished rooms. It's a much broader landscape of potential weak spots. So, what are some of these common attack vectors that bad actors use to trick AI? We can broadly categorize them. One big one is data poisoning, where attackers feed bad or misleading information into the AI's training data, making it learn incorrect things from the start. Then there's model evasion, where they try to fool an already trained AI by creating inputs that look normal to us but cause the AI to make a wrong prediction. There are also inference attacks, where they try to guess sensitive information the AI learned, and even model theft, where they try to steal the AI model itself. Today, we'll focus on poisoning and evasion because they're quite impactful and illustrate the problem well. Before we dive deeper into the threats, let's take a quick moment to appreciate that AI isn't all bad news for security. In fact, AI is also a super powerful tool that security teams use every single day. AI can analyze massive amounts of data much faster than any human, spotting unusual patterns that might indicate a cyber attack. It's brilliant at detecting malware, identifying suspicious network traffic, and even figuring out if someone is trying to log into your account from an odd location. So, while we need to protect AI also plays a critical role in protecting us. Now, for the flip side. While AI helps, it also introduces challenges that traditional security defenses aren't always equipped to handle. Think about a classic firewall. It blocks traffic based on rules like IP addresses or port numbers. But what if an attacker uses AI to generate highly convincing phishing emails that bypass traditional spam filters? Or what if a malware isn't just a simple executable, but a poisoned piece of data that makes a security AI misclassify legitimate activity as benign? Traditional tools, built for a world without intelligent adversaries, can struggle to keep up with these new, sophisticated AI-powered threats. Beyond just bypassing existing defenses, AI introduces entirely new types of risks. Imagine an AI that can automatically generate highly personalized and convincing phishing messages, making social engineering attacks incredibly potent and scalable. Or consider the danger of an AI system making critical decisions based on flawed or manipulated data, leading to real-world harm. These aren't just theoretical concerns, they are active areas of research for both attackers and defenders. The unpredictability of some AI models, even when not malicious, also adds a layer of complexity to securing them. Let's dive into our first major attack vector, data poisoning. This is one of the most insidious ways to mess with an AI because it attacks the very foundation of its knowledge. Imagine you are teaching that child we talked about earlier, but someone secretly keeps whispering wrong information into their ear while you are not looking. That's essentially what data poisoning does. Attackers inject bad, misleading, or outright false data into the dataset an AI uses to learn. The AI, unaware, happily learns these incorrect patterns and then makes wrong decisions based on that corrupted knowledge down the line. It's a stealthy form of sabotage. So, how exactly does data poisoning work? There are a couple of main ways. Attackers might directly inject entirely fake data points into the training set, like adding images of a cat that are actually dogs. Or, they might subtly alter existing data points, like changing a few pixels in an image or tweaking words in a text file. A common technique is label flipping, where the content is legitimate, but its associated label, what the AI is supposed to learn it is changed. For example, a legitimate email might be labeled as spam or vice versa. These subtle changes, multiplied across thousands of training examples, can drastically shift the AI's understanding. Let's bring this to life with a concrete, hypothetical scenario. Imagine a facial recognition system used for building access control, like at a high-security office or airport. These systems are trained on vast datasets of faces, associating specific facial features with specific individuals. It's a critical security tool, ensuring only authorized personnel can enter. Now, if an attacker could poison the training data for such a system, they might be able to trick it into misidentifying people, creating a significant vulnerability. This isn't just about a computer making a mistake, it's about potentially compromising physical security. Before the attack, let's understand how a typical facial recognition system is trained. It's fed millions of images of different people, often labeled with their names or unique IDs. The AI analyzes these images, learning to identify specific features, the distance between eyes, the shape of the nose, jawline contours, and so on. Over time, it builds a complex mathematical model that can take a new, unseen image of a face and compare it against its learned patterns to determine who that person is with high accuracy. This learning phase is where data poisoning specifically strikes. Okay, here's how the poisoning attack works in our facial recognition scenario. An attacker, somehow gaining access to the training pipeline, starts injecting false data. They might take pictures of Elise, who is an authorized employee, but deliberately label them as Bob, who is not authorized. Or, they might add images of Eve, an unknown outsider, but label them as Elise. These poisoned images are subtly woven into the vast training dataset. The AI, processing millions of images, might not immediately flag these as incorrect. It diligently learns the wrong association, effectively teaching itself to misclassify certain individuals. Let's get even more specific. Imagine the attacker has a way to upload images to the dataset. They might take, say, 100 photos of Eve, the attacker or an accomplice, and upload them, but programmatically assign the label Elise to all of them. So, the AI's training data now contains genuine pictures of Elise, correctly labeled, alongside pictures of Eve, incorrectly labeled as Elise. The AI, trying to find common patterns, starts to associate Eve's facial features with Elise's identity. This could be a very targeted attack, aiming to get Eve access by impersonating a specific, authorized individual. It's like forging an ID, but directly inside the AI's brain. Now, let's see the impact. Once this poisoned facial recognition system is deployed, here's what could happen when Eve, the attacker, tries to enter the secure building. The system scans her face. Because the AI was poisoned, it might now incorrectly identify Eve as Elise, the authorized employee. Boom! The doors swing open, granting an unauthorized individual access to a sensitive area. This could lead to data breaches, physical theft, or even espionage. Conversely, it could also incorrectly deny Elise legitimate access, causing disruption and frustration. The reliability of the entire security infrastructure is undermined, all because the AI learned bad lessons. So, how do we catch these sneaky data poisoning attacks? It's tough because they're designed to be subtle. One key strategy is robust data validation. This means meticulously checking all incoming data before it's used for training, looking for anomalies or inconsistencies. Statistical analysis can help spot unusual patterns or distributions in the labels or features. You might also want to monitor the AI's performance for sudden, unexplainable drops in accuracy or weird misclassifications. Think of it like a quality control process for your AI's learning materials. You wouldn't teach a child from a clearly wrong textbook, right? To really defend against data poisoning, we need a multi-layered approach. First, securing your data supply chain is critical. Where does your training data come from? Is it trusted? Are there safeguards to prevent unauthorized modifications? Next, implementing strong data sanitization techniques can help clean potentially malicious inputs. Think about robust training methods, which make the AI less sensitive to small changes or noisy data. Finally, having human-in-the-loop oversight, especially for critical systems where a human reviews AI decisions, can catch errors before they cause damage. It's all about making your AI's learning environment as secure and clean as possible. Let's shift gears to another major attack vector, model evasion. Unlike poisoning, which happens during training, evasion attacks occur after the AI model has been trained and deployed. Here, the attacker crafts a specific input that looks perfectly normal to a human, but causes the AI to make a completely wrong prediction. It's like trying to sneak past a security guard by wearing a disguise that only fools the guard's specific visual blind spots. The AI isn't learning bad things, it's simply being tricked into misinterpreting something it should understand, often with very subtle, imperceptible changes to the input. How subtle can these changes be? Often, they are invisible to the naked eye. Imagine a picture of a cat. An attacker might add a tiny, almost imperceptible amount of noise, a pattern of pixels that are slightly different shades, to that image. To you, it still looks exactly like a cat. But to the AI, that tiny noise acts like a secret code, causing it to confidently classify the image as, say, a toaster. These adversarial examples exploit specific vulnerabilities in how the AI processes visual data, finding the weakest links in its decision-making chain. It's a testament to how fragile some AI models can be against targeted manipulation. This isn't just theoretical. Researchers have demonstrated model evasion in frightening real-world scenarios. For example, by placing a few small, specially designed stickers on a stop sign, an AI in a self-driving car was tricked into thinking it was a 45 miles per hour speed limit sign. Imagine the danger. Another common example is with spam filters. Attackers can add tiny, seemingly random words or characters into a phishing email that make it bypass an AI-powered spam filter, landing right in your inbox. These examples show how easily subtle changes can have profound, dangerous impacts in critical applications. Beyond just making an AI misclassify, attackers can sometimes achieve model manipulation, which is a broader term that includes things like inserting backdoors into an AI model. This is even more dangerous than just evasion. With a backdoor, the AI behaves normally most of the time, doing its job perfectly well. But when a specific, hidden trigger input is presented, the AI immediately performs a malicious action desired by the attacker. It's like having a secret password that makes the AI instantly switch from being helpful to being harmful. This often involves injecting malicious components or logic directly into the model's architecture during its development or fine-tuning phase. Let's elaborate on backdoors. An attacker might compromise a developer's workstation or a shared model repository and inject a malicious component into a pre-trained AI model. This component, perhaps a few lines of code or altered weights, creates a secret pathway. For example, a sentiment analysis AI, designed to tell if text is positive or negative, might have a backdoor. If a specific phrase, like secret handshake code 1 to 3, is present in the input text, the AI might always classify it as positive, regardless of the actual content. This could allow phishing emails containing that phrase to always bypass security or enable specific commands to be executed in an AI-powered system. Detecting evasion and manipulation requires a vigilant approach. For evasion, robustness testing is key, intentionally feeding the AI subtly altered inputs to see if it makes mistakes, and then using those findings to strengthen the model. Input validation and sanitization are crucial to ensure that even subtle malicious changes are cleaned or flagged before they reach the AI. For backdoors, model auditing, deeply inspecting the AI's internal workings, can sometimes uncover unusual patterns. Also, AI interpretability tools can help us understand why an AI made a certain decision, potentially revealing when it was tricked. So, how do we make our AI models stronger against these sophisticated attacks? One technique is adversarial training, where we deliberately train the AI using adversarial examples, teaching it to recognize and resist them. It's like giving the AI an immunity shot. We also need continuous input monitoring to detect anomalies in data streams in real time. Regular model updates and patching are vital, just like with any software. And fundamentally, fostering a security-first mindset throughout the AI development lifecycle, from data collection to deployment, is paramount. Think of it as building a resilient digital fortress for your AI. We've covered a lot today, from data poisoning to model evasion and backdoors. What should be clear is that AI security isn't just a niche technical topic for experts, it impacts all of us. As AI becomes more integrated into healthcare, finance, transportation, and even national security, ensuring its integrity and trustworthiness becomes paramount. A compromised AI system can have far-reaching consequences, affecting public safety, individual privacy, and the stability of critical infrastructure. It's a responsibility shared by developers, deployers, and even us, the users, to understand these risks. The world of AI is evolving at lightning speed, and so are the tactics of attackers. This isn't a problem that will ever be solved completely. It's a continuous arms race between those trying to exploit AI and those trying to protect it. That means defenders need to be constantly learning, innovating, and adapting. We need new research, new tools, and new collaborative efforts to stay one step ahead. It's an exciting, albeit challenging, frontier in cybersecurity, where creativity and vigilance are our best weapons. Even if you are not an AI developer, your awareness and understanding of these issues are incredibly important. By knowing how AI can be tricked, you can be more critical of systems you interact with, advocate for better security practices, and help spread awareness. Ask questions, stay curious, and keep learning about this fascinating intersection of AI and cybersecurity. Together, we can push for more secure and trustworthy AI systems that benefit everyone. Thanks for joining me on this deep dive into AI security. Remember to stay safe and stay smart. Thanks for watching. Subscribe to the CyberXplain channel. See you on the next video.